All right, welcome to a demo of Cursor Hero, which is a tool that I'm working on. I don't really know what it is or what the goal is, but it's in the direction of something that is robotic process automation and giving information about UI to an LLM to help interact with the computer. Because what I find is that when I'm using ChatGPT, I also have VS Code open, and I'm frequently copy and pasting code from it and manually formatting my responses, when really that information is stuff that's programmatically accessible, either through the disk or through reading the UI of what's on the screen. So one of the end goals is to make it easier for machine learning models to interact with the computer in a way that a human does. So humans are using mouse and keyboard, and LLMs are using text. So there's a bit of a disconnect. And the LLMs can write code, but that still involves us copy and pasting that code into an editor. So there's many integrations that solve this. And this is just a tool that I'm working on. So right now, I'm using an Xbox controller to control this character in the game. And that character has its own pointer in the game, and that translates to Windows mouse position being updated. So that lets me move around and click things. So when I press right trigger, it actually sends a mouse down event. So that lets me interact with the computer using the gamepad. And this is already lets you do a lot. Like I can create and edit files with this. So it's a bit finicky, but it works. So if I do new file, then I can say text file, and that works. But there's room for improvement upon this. So if I press in the right stick, it'll focus the window again, and you can see what's going on is that it's recording all of my monitors and putting them into the game world. And in addition to that, there is a tool system. So I've added a bunch of different tools that let me add button bindings in a way that's very extensible. So for example, there's a chat tool. So if I hit enter, switching back to the mouse and keyboard, I can say hi, and that puts a chat bubble below my character. So that's one tool. There's also a tool that just makes me move around when I use the left stick. So basically every input is bound to a tool. And one tool that I made is the taskbar tool. Oh, I think the game just crashed. I have a few too many programs open right now. Let's try this again. So the taskbar tool will look at the elements in my taskbar and will create a wheel around the character. So now I can jump to any item, and when I activate it, it will move the pointer and click on it. So using that tool, you can jump to an open program. So this is kind of building integrations with the operating system through the use of the UI automation stuff that is available. So one of the goals, interesting, is that the calculator app has controller support. So moving around in the game is actually sending the inputs to the calculator as well. So if I hit the A button, it's actually sending the inputs, which is not quite what I want right now, but whatever. And one interesting aspect of designing something like this is that when you're using the controller, the game window isn't actually focused. So I've had to switch some backend libraries in the Bevy game engine so that the game still receives controller inputs. That was a little tedious to get working. And the other thing is, like when you send a click event, which is, I need to go back to the main wheel. So when I click, it's by virtue, it's unfocusing the window. So that's why using the controller is actually easier than using the mouse and keyboard, is because if I were to try and have it, using the mouse and keyboard right now, if I were to click on this in the game and have that translate the click into that window with the mouse and keyboard, it would teleport the mouse and click there, and then the window becomes unfocused, and then that just causes problems. So having the controller as a something that's always being read makes it a little more straightforward. So let's try and focus up here. What do I want to talk about? So the UI automation stuff. Let's go full screen. There's many tools available to help peek at what's going on inside of Windows. So one of them is inspect.exe, which shows you the tree of all the stuff that's open. So what I will do is, let's move VS Code over to this monitor. And I will full screen this. Let's put the character over here, move the camera. So I'm only recording my main screen, but using this, I can kind of show you what's going on my other monitors as well. So in Inspect, we can see that, there we go. We can see that there is the elements for VS Code, and we can kind of drill down in the tree and see what the different parts of the application are. And this lets us, this exposes the inner parts of the app. So if we look inside, then the file bar at the top here, we can programmatically see that the bounding box of this element with this text is at that location. And we can use the game to interact with this as well. So it keeps freezing. I think it doesn't like having all these tools open. It's a little more stable when I don't have several inspection tools open. There we go. So using the UI stuff, we can create a tool in the game that will let us peek at these elements. So if I click on the spot, it'll actually clone that part of the screen, reading the UI automation to detect the bounding box of the elements that I'm hovering over. So I don't quite know what I'm going to use this for. I think the goal is to take the UI tree that I'm scraping from VS Code and other apps to create a payload that we can feed to a LLM. So if we look inside here somewhere, UI watcher results.txt, this is the UI tree for VS Code. The other thing that gets weird is I don't quite know where to look, because I have VS Code on my right monitor, and then I have the game on the main monitor. So I'm looking at the game, even though this is also on the right monitor. So we can see that the full UI tree is quite extensive at 800 lines, basically just for VS Code in this case. So we want to trim this down to just the parts that we want to feed to an agent. So if I were to say, my program's not working, help me figure out what's wrong, then using this UI automation stuff, we can scrape the hierarchy. The other thing I need to fix is it locks my mouse when it thinks I'm in controller mode. So when I switch between them, I have to tab to the game, send a keyboard input. Come on. There we go. So now the mouse is freed, so I can scroll. So if I said my game's not working, help me figure out why, then the text in my console is also part of this. So if I control F for some of this, it's very strange. If I delete this, is it actually refreshing? I might have turned off the system that's loading this. Why are you not running? It's supposed to be continuously overwriting this file with the contents of the UI tree for VS Code, and I'm not quite sure why it's not. Let's try running in debug mode. So while that's loading, one objective is to programmatically scrape the UI elements of any application. In this case, I'm starting with VS Code, and use that to create a text payload that can be used as context for an LLM to help solve problems. And this will turn into giving the LLM access to a virtual controller to operate inside the environment the same way I am with my actual controller. So reducing the input space from a keyboard and a mouse to a controller with just 2 sticks and several buttons, I think is interesting. So now the window's all the way over here. Let's move it there. And what was I trying to do? This results thing. So now it's actually updating properly. And if I search for like that, then we can see that that text in the console is available inside what is being scraped from the UI. And then what was happening earlier is that now, because that text is in the console and in the text buffer, it's actually showing up, and now it says 3 out of 3. So we can see that it gets very weird working with this stuff, because it's all like the screen recording gets kind of recursive, and then looking at the UI tree for VS Code itself also makes doing stuff kind of loop back on itself. So one thing that I want to look into is transparent windows. So right now the game is its own like windowed application, and it has a full screen mode, but when you're working in VS Code, you want the, like if I was to add, you don't want to have to focus on the game window, and you'd rather just like look at VS Code and have, if there's like additional decorations or whatever that I'm going to add next to the mouse, like some kind of clippy thing, then that would want to draw transparently over top of this. And there's currently an issue with the Bevy stuff that is this. So I think it's in WInit. There's a problem with transparent windows where it's just not working. So that's one issue. And then the other thing that I thought was interesting is that the zoomit.exe does do something where it's capturing the contents of the screen and zooming in and then drawing that back to the screen, but in a way that doesn't conflict with itself. So presumably zoomit is drawing over the content of the screen right now, but it's still interactable. So I'm not sure how that's working. So I want to delve into that. And there was a good Microsoft Ignite talk where they showed some of the source code. So I'm going to be looking and seeing if I can get more of that. What else did I mention I wanted to talk about? Zoom it. Can't close the window with the X button. So if we go to the game back, which is still freezing, I think this is freezing because of all the inspect stuff. So what I'll do is I'll show you this. So this is inspect.exe, which you can find just by Googling. And it has the UI automation. And then there's the older kind of UI tree that it can also show you. And this is good because it lets you actually drill down in the tree. And then there's accessibility insights, which is the newer one, but doesn't quite have the full tree. It just shows what you're hovering over. So if I hit play on this, it will follow what I'm hovering, and it will drill down into the hierarchy for that. So we can see like all the, I clicked on video talking points, and now we can see all the other UI elements next to it. So that, these are just tools that you can use to kind of see what Windows has available. And then there's ACK event, which we hit start listening here. Then it lists, it listens to the events that Windows send and stuff. So if I change what I'm selecting, then one of these events somewhere in here is an event that says I've changed the selection from one thing to another. So you can listen to that and create a stream of events and kind of record what you're doing. So you can, like I'm using the screen recording software right now, but if you wanted to have a detailed annotation of how a programmer uses their IDE, then recording that kind of event and saying like they changed the selection and that caused the text buffer to change, you can get a lot of information from this kind of stuff. So I'll close that because I think these tools are what is kind of causing this to crash. And then another interesting one is process monitor, or procmon. So you can see like what registry keys is a given program touching, what files is it manipulating. And this is all just kind of inspection stuff, which is neat. So now that the game is, so we talked about zoom it. Come on. Another interesting thing is using the app. I can move it around with itself. So within the game, using the controller, I can mouse down on the title bar and drag around the window itself, which is kind of neat. So what I did is I made, when you press in the left stick, or sorry, the right stick, it will focus the window. So if this was in behind something, come on. So the calculator's in front, press on the right stick, now the window becomes focused. And then also when you press it in, it will move the pointer to the title bar, which I think I've broken recently with some logic. But the idea is that you can manipulate the window, other windows, and itself from within the game. But one thing I've observed is that hitting the X in the top right, it will freeze instead of closing. So like I can't minimize and I can't close, because I think there's something about message loops or whatever where it doesn't like that. But I think I can close it from the tray. So if I click on this X button, so that works. So we talked about using a controller, talked about the inspecting utilities. Another interesting tool I made was the restart tool. So one of these, this one. Oh geez. Sends Control-C, up arrow, enter. So if I go to VS Code, and then focus on the terminal and hit start on the controller, it will send the inputs required to restart the game. So one goal is to be able to work on this with a controller and not have to switch back to the mouse and keyboard. But obviously programming with a controller is going to take a lot of assistive tooling to get parity. And then now for the other interesting stuff for the people who are still watching. What I will do is turn on the necessary parts. So we need text-to-speech. We'll click that and it will turn, it'll open a terminal, at least it should. That one worked. Something very strange is going on. That should not be. Oh, but yeah, I think I know what's going on. So using, not the controller, I will click these with the actual mouse. And when I click those, it's opening up Windows terminals with some predefined commands to get some tools started that is going to be used for this next part. So we have voice to text, which is a Python program for using Whisper to transcribe what I'm saying out loud. So when this loads in a second, then let's go here. And when I press F23, it will start listening. So if I go here and then say something out loud while holding the hotkey, it will transcribe what I'm saying. So that's a standalone tool that I made, but the integration that when it launches through the button, it will stand up a web server so that the game can communicate with it. So when I press the select button, what is it, start select? There we go, starting listening. So hitting start will make it always on, and it will transcribe what I'm saying into messages in the game. So that's one piece of the puzzle. And then the next piece is, if we go down to this environment, there is a character that is meant to be the agent. So it is listening to the messages that are appearing as I talk. What we have to do is, though, is turn on its observation tool so that it has the ability to respond. So now that character will observe the messages that I say, and it will use Ollama to generate a response. Oh boy. I think they got catapulted so hard they fell to the other environment. Let's try restarting. So another thing is that I can restart the game and the other components independently. So even though I started it from the game, it's still listening and doing the correct stuff. So I think I might have to turn the listening back on. That's not correct. Oh, there we go. And then, because the game restarted, we have to turn on the observations.
It seems that you need some assistance with your project. Is there anything I can do to help?
What do you think you could do to help?
Well, I can analyze the code and identify any errors or potential issues that may be causing problems with the game. Additionally, if you need any new functionality added, I can work on implementing those features for you.
Interesting. Tell me a joke.
Knock knock. Was there?
Who? Who? Sometimes the text-to-speech isn't the greatest. So let's just... Oh boy.
I see what you mean.
Sorry, can you start the joke over again?
Let's try this again. Understand the text properly at times. However, I will continue to improve my understanding of natural language so that I can communicate more effectively with you in the future.
All right. So that didn't quite go as planned, but that is...
Oh, I see what you mean. It can be a bit challenging to understand the text properly at times. However, I will continue to improve my understanding of natural language so that I can communicate more effectively with you in the future.
The character for the agent, and inside the agent there is a buffer that holds all the observations of what it has seen. So that includes all the chat messages, including all the mishaps. And this is persisted, so when I restart the game, it knows
it seems like there might be an issue with the game environment,
it also
specifically with the communication between the agent and the program.
Events that it detects
I will try
from when the game
is
started over again. So looking inside the restart memory, we have the agent memory, so we can delete that, and it will forget everything that's been said so far. Tell me a joke. Tell me a joke.
Knock knock. Not your business, sir.
Can you explain the joke?
The punchline is a play on words. Not your business implies that it isn't appropriate to ask about who is at the door. This is humorously reversed to imply that a theatig isn't talking because it's not too mean as business.
All right. So going back to the VS Code stuff, let's turn off the always listening and then focus the game so I can use the mouse. There we go. And then we need VS Code. So let's put you over there. If we have the observation tool, one thing I want to do is take this. So using the UI automation stuff, we can detect the bounding box and clone the texture for that region of the screen and put it on a brick in the game. But what we can also do is attach to that brick the UI automation information. So this, the idea is that you would kind of screenshot VS Code and then you would bring that brick down into the environment with the agent and kind of show it, say, here's what's going on, help analyze the problem. And this would be something that it could observe, including all the contents of the stuff. So not the raw UI tree that's very kind of dense, but we would do some processing on it to give it just the information that actually matters. So again, the results.text. So this tree contains all the information about the stuff inside the window. So I just need to prune this down to just to a formatting that makes sense. Say like, here's what files you can see in the Explorer. Here's what's going on in the terminal. Here's what's in the text buffers. And that will be the next step. And that's kind of what I've got going on. I don't know what I've missed. Let's go templating system. Oh yes. So for this, I made a tool to help add functionality to the game. So if I wanted to add a tool, then let's see if I can do this with the controller. See how far. I haven't actually demoed or tried this before. So let's go here. We need an icon for the tool. So what should we add? Create an icon for a popsicle tool. And then we'll go keyboard mode, and I think that's the return key. There we go. So in keyboard mode, we have access to control, down arrow space, shift, the Windows key, really? Okay. And then backspace and tab. So you can do some very primitive text editing with this. And then the microphone tool lets us hold a button to do push to talk to transcribe what we're saying. So that's our image. Let's save this into the game. So this is the hard part, is doing very fine adjustments on the text is not quite there. So I think I can do control backspace, delete a bunch of words. Go right, delete. Popsicle tool. So that is not the correct formatting, because it should be snake case like the others. So that's as far as we can go with that, and we'll just do the rest by hand. A little bit of cheating. So now we have the picture for it, and we need the actual implementations. Where's VS Code? Inside here, using the D-pad, we can scroll up and down, and then the sprint button lets us adjust the speed of that. So inside templates, we want to apply the template for adding a new tool. Come on. So sometimes you have to be very precise with the cursor movements, and sometimes you just want to get from one side of the screen to the other. So that's one challenge of using the controller instead of a mouse. And in this case, we want to create a tool. So that is pattern 2. So that will create all the files necessary for that. So it's going to create the crate for the tool itself, and then a crate to hold the types. And then it will register it into the plugin that registers all the other plugins. And this is a fairly straightforward templating system. And I don't think the tool template is actually working the greatest, so that's not the best one to show. Come on. Like if I were to run this, it'll probably encounter some errors because I'm still fleshing out that template, but a template for just adding a generic plugin is also working, so we can try that if this doesn't work. So while that's loading, I'll show you how it actually works. So this templates folder has a folder called patterns. So the new tool pattern is going to create, it's going to adjust cargo.toml for the workspace. And there's stuff that's going to go before what we're adding and the stuff that comes after. And this, I don't think it's Jinja that I used for this. What did I do? So choose the pattern, get the folder, and then inside the pattern, we need to ask for some variables. So there's a Python file to ask for the crate name, and then crate name Pascal becomes a global variable that can be referenced within the patterns, or the whatever. So the cargo.toml for the new crate gets prepended with some stuff and has a suffix, and it sets up the dependencies and stuff. So this lets us prompt for variables and then filling out the content of the files. And then some of them are editing things that already exist. So the plugins.lib this has all the plugins that are being registered. So when we add a new tool, we have to add to the top the new things that we're wanting. So there's all the use statements, and then we're adding the new use statements for the tool we're just adding, and then the start of the plugin, so that's like this crap, and then the new stuff, and then whatever's remaining. So how does this get determined? That comes from the matchers folder, which gets generated according to the patterns. So there's a notebook that will look at all the patterns, identify the variables, and some of the variables are global. So it's crate name and crate name Pascal are the global variables. And then the rest of them, it will create a file. So we look at crates, plugins, lib. So it creates a .py file that will ask for the string that it should search for to create the delimiter. So if we look at this one, how does it know what the use statements are, all the existing ones? Well, it says find pub_struct my plugin, so this line, and then up to but not including that is what use statements is. So that gets set to the text in the index. And this gets scaffolded out for each of the variables. So the generate matchers looks through the patterns, and then it will actually output the Python skeleton, and all you have to do is replace the stuff inside the quotes, and it will write the rest of this for you. So standard kind of code generation. And then the other thing is that if it matches, so in this case, I have two patterns, new tool and the new plugin with types, and both of those edit cargo.toml. So this would generate, they each have a cargo.toml.py to identify what parts the variables come from. So before first plugin dependencies, in both cases is this string. So it detects what the similarities are, and it will copy and paste the Python implementations depending on if they match. So that's the templating system that I've kind of been working on. So I think that's most of the stuff I meant to mention. Looked at the agent, looked at the templating system. Next steps. Oh boy. Come on. I don't know why it's freezing. It hasn't been doing that. Maybe it's because of OBS or something. So in the game, come on. So our popsicle tool got added, but I think our image was wrong. So we go here. ChatGPT is now downloading as WebP instead of PNG. That changed at some point. Now we have a popsicle tool with a key binding that can be used. So I'm surprised that worked, but I'm glad. Next steps. So these buttons are running a WSL command that's relying on paths and stuff about how I've set it up. So if anyone else were to try and use this, it would require them to set things up in a very specific way. So more customization on that front would be good. And what else? This, so the agent stuff, one idea was to create a fake operating system that it could manipulate. So in this case, there's like a start menu. Come on. And I haven't gotten much further than that. So giving it access to an environment where it can explore and click on stuff without worrying about it like shutting down the computer or clicking on something that it shouldn't. That is one idea. And the architecture of this is such that many of these could be running in parallel. So like a reinforcement learning thing where you have many environments with agents doing exploration and receiving rewards is one potential objective. But really, there's not much set in stone for what this is going to turn into. I think the stuff I've been working on most recently is the UI inspection for VS Code to get the tree and then feeding that text to the agents down here and saying like asking questions and getting answers about it. And then I need to switch to a different model in Olama. So if we go here, I forget which one I'm using right now, but it's not, the model I'm using is not tuned for programming. So I'm probably going to switch to Mixtral or Gamma and then see if I can get some fine tuning on that once I actually have some text and responses coming out. And so if I say, oh, interesting. It was denying that it even knew about VS Code earlier.
Stands for Visual Studio Code, and it's a text editor used for programming languages like Python and JavaScript. FN main.
Interesting. Is that really? I wonder why it stopped. I guess it's only allowed to do one line at a time. I think is the way it's doing the chat right now. Yeah, that's what I have so far. Any other tools I'm missing? So like the worlds have a little border that will bounce you back into the world. So if you move the camera and then teleport the character, then you can kind of hop between them. It's just implementation detail, but it's kind of fun to see. So I'll turn that off, and then if I clone some stuff, then there's like a gravity thing, so you can kind of flail these around, and that's kind of fun to mess with. One idea was a kind of zombie game where it looks at your Discord, and all the members in the Discord server would become kind of enemies that are approaching you, and you have to shoot them or something. So scraping the UI for game purposes is also one opportunity. And then this kind of like brick thing where creating bricks that contain information about the UI and passing that to the agent is, I don't know how deep to go with that concept. Like it's, instead of cloning it at full size, then I have like a shrunk representation of anything and then attaching metadata to that and then letting these become something that the agent can observe. That's one avenue for future development, but haven't done it yet. That's the demo. So this is available on GitHub. Yeah.